Okay, so now we have a new triangle. We have a 1, 2, and some unknown side triangle. And I can see that there's some letters here, A, B, C. And these capital letters, A, B, C, refer to the angles. And the question here is, what is tan theta? Now, tan theta, we recall from SOH CAH TOA. SOH CAH TOA. Tan is equals to opposite over adjacent. So we can now attack this. Tan theta, you stick your finger here, that's your hand, is equals to the opposite over the adjacent. And unfortunately, we don't know what the adjacent here is. I'm just going to call this lowercase a. By convention, the rules are that the capital letter is the angle, and then the corresponding opposite side, the lowercase letter, is the side. So this here is lowercase c equals 2 because it's across the 90-degree angle. And of course, across the b, we have this 1 happens to be the lowercase b. So the question here is, what's tan theta? Yes, it's going to be the opposite, which is 1 over this unknown variable a. But we don't know what a is. Good thing that we know what Pythagorean Theorem is about. Because when we have a right triangle, we know that c squared equals a squared plus b squared. So we're going to just use the c happens to be 2. 2 squared equals the a squared, which is unknown. It's what we're trying to solve. Plus the b squared, which happens to be 1 squared. So a squared equals, this happens to be 4. And 1 squared is 1. When you throw 1 over the equal sign, we have a negative 1. So a squared is equals to 3. In math, you have an equal sign. You're allowed to take the square root of both sides. So we have a is equals to the square root of 3. We're only interested in positive lengths, positive values, because we're talking about a physical triangle. So a happens to be root 3. So in future math, it's good to memorize this triangle. 1, 2, root 3, where 1 is the shortest side, 2 is the longest side, and this unknown side is root 3. This is easy as 1, 2, root 3. All right, so we now know what the a value is. The a value is root 3. So we have tan theta is equals to opposite over adjacent, which is 1 over root 3. Excellent. If, for example, you checked the back of the textbook or found some answer key and you found that the answer was something different, such as root 3 over 3, let's think about this. Yes, this answer is correct, 1 divided by root 3. And you may use your calculator and realize that 1 divided by root 3 is approximately 0.577. And the decimals keep going on forever. But if you think about it, root 3 over 3 is also equivalent to 1 over root 3. Now, why is this the case? So you're not wrong if someone writes root 3 over 3. Let's try rationalizing this. The word rationalize means to get rid of the square root from the bottom. And when you multiply by same over same, that's equivalent to multiplying by 1. Any number, numerator and denominator, when they're the same, essentially becomes 1. So how do you get rid of the radical from the bottom? We're going to multiply by root 3 over root 3. So when you copy this over at the bottom and the top, and this is okay in math, because when you have same divided by the same, it ends up being 1. Anything times 1 is itself. It's essentially the same. This is a clever trick to get rid of the radical from the bottom, which is called rationalizing the denominator. So let's multiply across. 1 times the top here becomes root 3. Anything times 1 is itself. And root 3 times root 3, the radical sign disappears. When you have the square root of a times the square root of b, in general, the answer is the square root of a times b. So when you have root 3 times root 3, we get root 9, which is 3. The faster way would be to simply copy down the inside, the radicand. So yes, indeed, 1 over root 3 is root 3 over 3. Now in the next video, we're going to focus on the big other step, which is to find the Holy Grail angle. How do you find this angle? Stay tuned.